Hello everyone, I am Rohit Purkait, and since I have been traveling to a lot of places and attending a lot of events, I am seeing that a lot of people are building a lot of things without knowing the basics of it. Right? I see a lot of people building DAOs, building IDEs, building ENS even, but they don't know the basics of it. So I am again traveling through all the basics. I am trying to teach myself everything since the beginning, and along the way I will be creating these small videos so that in order to teach everyone that how everything works, so that the next time they are building something they will be able to know that what they are building, right? Not just blindly vibe coding. So today I am covering a very basic topic, ENS. Now I will be building the entire ENS, how everything works, but today we will be going with the basic, right? So what do you mean by ENS, right? To understand it simply, I think we might, like every one of us uses UPI, right? Now in UPI we might see that whenever we use, like let's say Rohit at the red UPI, then it automatically like redirects everything to our bank address, right? So let's say I want to pay someone like rohit.upi. Now whenever we like type on that, then automatically in the background it automatically redirects to our bank account that is connected to this UPI ID, and as a result of which when we pay this particular name or string, then the money automatically transfers to the bank account, right? So ENS can be thought of something similar. So here, like a particular name or a string is attached to a wallet address at the very core of it. So let's say if I say like rohit.eth, then it's connected, like whenever I put that into a wallet or something, then it's connected to some wallet address. So whenever I pay to this string, then automatically the payment is sent to this particular wallet address. So this is what ENS means, right? Now like to go further, ENS has a lot of more difficult like terminologies and a lot more complexity at its core, which I am not going to cover today. But today I am gonna try to write a basic smart contract. The smart contract will take our name and will map a wallet ID to it, right? So whenever we put a name to our smart contract, it should give us a wallet address that is associated to it. So the very core, right? So what is our required output? So first we want to register. What do we want to register? We want to register a name, let's say rohit.eth, and we want to register it to our wallet address, right? And then we want a function called resolve, right? So the resolve will take the input of the name and will give it the output of the wallet address. So this is the code we will be working with today, right? This much is clear. Now let's move to the contract part. The contract is pretty like simple. So for saving time I am just gonna go through each and every line. So the first line here is basically to determine the compiler version of Solidity. That's it. The next line we define the contract. This line is where we define our mapping. So as we can see in our previous diagram that this is basically a string, right? And we are addressing it to a wallet address. So here I am writing the same thing, right? Mapping. So we are mapping a string to a wallet address and we are naming it IDs, right? Now the functions that I mentioned earlier, that is register and resolve, we are basically writing that function. So function register. So here I have used call data. Why? Because call data makes this variable read only, as a result of which it saves a lot of gas. Now if you don't know what gas is and how can we save it, then like I can cover it in another video, right? But for now just remember that we are using call data in order to like make this variable read only, and as a result of which it saves a lot of gas, and external means that external user will be able to use it. On the next line we are checking duplication. So require can be said as a if statement, right? So you are telling that if like our IDs, like which is this map, contains the name like if any wallet address contains with this name, then like we should return name already taken, and if like there is nothing, then we can proceed to the next step. So if this is not clear, let me break it down in here. So this is our line, right? Require IDs name this. So if I write in simple if statement, it would be like if IDs name equal to address, let's say 0, then what do? We proceed for the initialization, that is like we set the name with the address, else we throw the error message that name is already taken, right? Else name is already taken. Now you might question that how does this if statement work, right? So first, in order to answer that, we have to know that what is being stored in IDs. When I tell that a mapping, right, in this line, as we can see, a mapping is stored in IDs, so it's basically an hash map, right? So hash map looks like this. So we are telling a string is being associated with a wallet address. So a string, let's say rohit.eth, is being associated with some wallet address, right? Now whenever we give, now this is being stored in IDs. Now let's say when we are trying to search for IDs rohit.eth, then it should return the 0x like the wallet associated with it. But if we search the IDs with a name that doesn't exist, let's say vivash.eth, right, then it should give the default wallet address that is all zeros, right? So this is the wallet address that is all zeros, and basically this is represented by address 0. So the address 0 represents the default wallet address. So in this line we are checking that if our name doesn't exist, right, then we proceed to like put the name into our mapping. But if the name already exists, then obviously it won't give 0 address, it would give the address that is already associated with it. So we will give the error name already taken. So this is the breakdown of this line, that basically we are preventing duplication, that if a name already exists, we are not allowing that person to register their wallet address with the same name, right? In the next line, since we have already prevented the duplication, on the next line we just initialize that name with the message.sender. So message.sender is basically the wallet address who is calling the function. So the wallet address who is calling the register function, that would be stored with the name that they are calling with. And in the resolve, it's pretty similar. Since it's a getter function, so we use that keyword view, and we say that if you give the name, we will return the address. So that is why, like in the resolve, with the name that is being called, we just return the ID's like name. So it would give us the wallet address. So like I have already like deployed the contract in base Sefolia, and as you can see that here I have already like used the command to this particular wallet address with like the register function I have called with the name Rohit. So my wallet address has been like initialized to this name, right? And on the next level we have tried to call this function with the resolve thing, and since we have given the name Rohit, our wallet address is being perfectly shown, right? So like this is the core basic of how ENS works. So this is it for today. Later we will cover more like advanced topic into it, and as I will be learning, you will be learning too. Thanks for following for so long. And I am not gonna like do a short kind of video, because I think that these are some of the things that needs to be taught at a similar pace, not at a fast pace. So if you are someone like wanting to build something, wanting to understand something, then I think these videos would be great for you. So thank you for following all along. Good night.